So right now we're seeing some spacecraft or some kind of something flying through our skies, and it's doing remarkable stuff. It's impressing a lot of people with high tech. And then we're talking about angels and demons, and there's a bridge to be able to get to something that just seems like technology, and then to something that is much more spiritual, and there's an entity involved. And that gets into like close encounters and the variations of that. Can you talk a little bit about, along with seeing these objects and land, there's some entities involved occasionally?
Well, I think you already brought it up. If you're seeing technology that violates the laws of physics, you know that's not our government. You know it's not the Russians or the Chinese, because they're subject to the laws of physics. And so people look and says, wow, it's amazing technology. And I say, well, tell me more details about this. They said, well, they appeared and disappeared and reappeared again. Physical objects don't do that. Or they made a sharp right angle turn at these 10,000 mile per hour velocities. Or there was no sonic boom when we went through the atmosphere at 15,000 miles per hour. This is not technology that's based on the physics of the universe. It's something that transcends the universe, which means we're dealing with something that is dual. And so I like the fact that this UFO phenomena is actually helping us Christians recognize, hey, this is evidence that we can use to prove to people there's more to reality than the materialistic realm. This is not Buddhism. You know, Buddhists deny the duality of creation, that there's a spirit realm and a physical realm. They just say it's all materialistic. Well, the UFO phenomena tells us, no, we're dealing with something beyond the physics of the universe.
And on that basis, that what we're seeing now is so technologically advanced, or appears so technologically advanced, but it's not falling in with any current technology that could exist in the universe, as your posit.
Well, for example, there was a congressional committee that brought in some of these people who are thinking, hey, we're being visited from aliens from another planetary system. And one of the individuals that testified said, these extraterrestrials have found a way to violate the law of gravity. Well, guess what? The law of gravity applies everywhere in the universe. That's something we astronomers have established. No matter where you go in the universe, all the way back to the cosmic creation event, the laws of physics hold. So if somebody says, hey, you know, they got technology that violates the law of gravity or allows you to go faster than the speed of light, right away you know you're dealing with something that's either a total hoax or it's something from dimensions beyond the universe.
Well, I'd love to pick your brain on this, because I see a lot on YouTube about Alcubierre drive. I don't know if you've heard of that. And so there's a lot of theoretical physics. So mass can't accelerate through space-time faster than the speed of light. You take exponentially more energy to do that. But you can move space-time faster, you can expand it or move it faster than the speed of light. As we see the universe, space-time of the universe is expanding faster than the speed of light. And so they're thinking, okay, well, let's create a bubble through electromagnetic something, I don't understand all of that, but let's create a bubble, and then let's create, and this is theoretical, but let's create something in front of that bubble that can produce an extreme amount of gravity, or somehow manipulate gravity to create a spike that would cause us to fall forward. And let's create something, and this is where it gets really theoretical, of something that can expand space-time.
Had reasons to believe. We interviewed the guy that came up with all that.
Oh, cool.
It's a physicist by the name of Gerald Cleaver at Baylor University.
Okay.
And he and his graduate students say, you know, there's a speed limit we can't violate, the speed of light. But he said, notice that in cosmology, the speed of light does not apply to the cosmic space-time surface. You know, that surface gets bigger and bigger every year. Dark energy is accelerating it at a greater and greater rate. Because we're not dealing with electromagnetic phenomena, there's no velocity of light limit. So he said, what would it take for us to take a physical spaceship and have it travel faster than the velocity of light? And basically what his graduate students came up with was, well, you've got to warp space-time. You've got to warp the space fabric of the universe. And they said, well, we can do that, but it takes a lot of energy to warp the space fabric. And so you're not really going fast in the velocity of light, you're just warping the space, so it actually looks like you're going faster than the velocity of light. But they calculated that if you had a spaceship capable of having 2 human beings on it, not 10, just 2, so a relatively small capsule, you would need to convert the mass of Jupiter into pure energy every second just to get a little bit faster than the velocity of light. So basically saying, yeah, theoretically it can be done, but practically there's no way that could ever be achieved.
Yeah, no, I know I've seen there's a number of hurdles with trying to get there. And from what I'm getting though, it seems that they're making progress. And so there's this like optimism and this like realism that this is like a crazy goal to try to achieve, but we seem to make it, like I heard at one time, it was like you almost need the mass of 2 universes converted into pure energy. And then they found a way to bring it down to something like Jupiter.
Well, you need to recognize there are journals of science that are where you get papers published by mathematical physicists where they're basically saying, mathematically, this can work. Physically, it's impossible.
Yeah,
but the math
engineering
works.
is the tricky part.
Right.
Yeah. The problem with the engineering is you got to consume the energy of the universe to make it work, and you realize that's not going to happen.
Yeah.
But people look at the math and say, hey, the math works, it's got to work.
Yeah.
So,
When they look at like Star Trek or Star Wars, you know, that'd be great, but you can't do that. I mean,
well,
you
there's a
would burn
book
up
you
with
can
that.
get called The Physics of Star Trek. And it basically shows you all the ways the Star Trek series violates the laws of physics.
Which is too bad, because I really like that,
So one of the questions I had was, if it seems like UFOs just keep being slightly ahead of us technologically, or like speed-wise at least. So like the Foo Fighters were ahead of us in World War II, but now we're past that, you know?
Right.
And do you think then this could be a possibility? Because they're thinking about, theoretically, it's possible to create a craft that can go faster than the speed of light. And theoretically, I think because you're in this bubble, the mass inertia thing is different, where you're not feeling the G-forces. There's other issues that you have to overcome, but you're not feeling G-forces. And so like NASA just came out with the X-59, which is supposed to be able to take away the sonic boom that planes make and diffuse it into just like a sonic thump.
Yeah.
And so like maybe there's ways, again, that you can create something that it's not going to create a sonic boom, but it's just a technology that we haven't found a way to overcome yet.
Well, astronomers are recognizing we can move spacecraft at very high velocities, not the speed of light, but we can get them going, say, half the velocity of light, or 25% the velocity of light. But the problem is the faster you travel through interstellar space, the more damage your spaceship's going to take. It's the E equals mc squared, c being the velocity of light. So if you go, say, 20% the velocity of light, your spaceship will suffer 4 times the damage from the particles in interstellar space you would get at 10% the velocity of light. And now the only way you can mitigate that is make your spaceship small. The smaller your spaceship, the less particles it runs into. So having a big spaceship's a problem. Moving at a high velocity is a problem. But astronomers have already calculated the only way we can send spaceships to the nearest planetary system, which is only 4 light years away, we got to make the spaceship smaller than 10 centimeters, and we can't go faster than 10% the velocity of light. And even then, you're looking at sending 1,000 tiny spaceships to the nearest planet, counting on the fact that over half of them will be destroyed before they get there. The other half will be partly destroyed, hopefully in different ways, so you get back some useful information. But it does mean someone as big as you is not going to be traveling from some other planetary system in a spaceship and visiting the Earth. That's important because that's the primary explanation for why we're getting this UFO phenomena. And these UFO beings are basically trying to sell that story. We're from another planetary system, we came here in spaceships, and we're here to give you a warning or to help you with your technology. You know, we're here to assist, and we know you guys are in trouble. That's the common story you hear. But from a physics perspective, we know that there's no possibility for any being or any spaceship constrained by the laws of physics to traverse interstellar space. Interplanetary space, yes, but not interstellar space.
That's a huge point, because the more I've looked into this, the more I've realized when anybody else looks into this, there's a huge number of problems all throughout the extraterrestrial hypothesis for making sense of this. Not only like the science, you look at the phenomenon itself and you start examining the things that are happening, and it just doesn't make sense that this would be an extraterrestrial thing. And we look at it theologically and say also the things that we're seeing here aren't, theologically aligned with an extraterrestrial thing.
Look at the travel times, because in order to have an advanced civilization on a planet orbiting a star, you need a star that's virtually identical to our star, the sun, in terms of its age and its characteristic features. We astronomers have been searching for 65 years, trying to find a star sufficiently like the sun that it could be a candidate to have a planet orbiting it, in which you got advanced beings with civilization capability. We haven't found a single one. And we've been searching literally for 65 years. What we know is at a minimum, they'd have to travel tens of thousands of light years. Well, if you're traveling at 1% the velocity of light, you're now looking at 1 million years to make a one-way trip. And a number of astronomers have calculated, okay, how long can the technology we've had since World War II be sustained before you run out of resources or your star is no longer able to support it? And the answer is it's only a few thousand years. It's not 1 million years. So.
And isn't it true, because we talk about the sun, but there's ones that are bigger than that you talked about as well, right? With the sun.
Well, if a star is bigger than the sun, it burns up much more rapidly. And it takes a long time for microbes to prepare the planet for creatures like us. And so those stars aren't candidates because they burn up too quickly.
Right.
And then stars that are smaller than the sun have a lot of flaring activity. And you can walk around in a Stone Age situation and be okay. But we had a flare, solar flare in 1859, that knocked out telegraph systems around the world. We get another one like that, you're looking at trillions and trillions of dollars of damage.
Right.
You're knocking out the GPS system, you're knocking out the electric power grids. And you'd have literally tens of millions of people dying in America alone, let alone the rest of the world, because we're now dependent on electricity to be able to refrigerate our food and distribute it. It's one thing when you only got 20 million people in the United States, it's another matter when you got 330 million. Now, we do have the technology to protect our power grids, but there's only one power grid in the world that's adequately protected, and it's not in the United States. So
interesting.
And at your ministry, Reasons to Believe, I love that you keep track of you make a list of, you have how many articles now that are showing the probability of finding life elsewhere in the universe?
You go to reasons.org/fine-tuning, it pops up a 300-page document that anybody can read, and at the end we give you the probability of finding a planet anywhere in the observable universe with the capacity to support advanced life. Not advanced technology, just advanced life. And that probability, even if you take into account that there are 10 to the 26 planets in the universe, that's 100 trillion planets, which is a high estimate. Even then, the probability of finding such a planet without invoking divine miraculous intervention, less than 1 chance in 10 to the 1600th power.
Wow.
And to put that in context, I'm from California. We have a lottery, and your probability of winning that lottery is about 1 chance in 100 million. Okay, that 1 chance in 10 to the 1600, that's equivalent to someone winning the California lottery 200 consecutive times, where you buy 1 ticket each time.
Wow.
So, or as one mathematician friend told me, it's no different than the probability if you don't buy any tickets at all.
Exactly. And that goes back to the fine-tuning,
Yes.
the universe and how God has made Earth for us to live here. And you think of all the galaxies out there, and you think, if they're there, what are they there for? You know what I'm saying? If there's no life anyplace else.
Well, we got 2 trillion galaxies in the universe, and I run into a lot of atheist scientists who say, hey, If God wanted us human beings, he'd only need one star, one planet, maybe a moon, maybe a few asteroids and comets. The rest of it is a waste.
Right.
But what they're not taking into account is that the mass of the universe determines what elements you get. The universe begins with only one element, hydrogen. And as the universe expands, it cools down and goes through for a brief few seconds, the temperature window in which that hydrogen can be fused into helium. And if you fuse too little hydrogen to helium, future stars cannot make any elements heavier than helium. And if you make too much helium in those first few minutes of the existence of the universe, then the future stars quickly convert everything into elements heavier than manganese. In both cases, you have a universe with 0 carbon, 0 nitrogen, 0 oxygen, and no possibility for life. It must be exactly the mass that it is for the 4 of us to be here today.
It shows just how awesome that our God is, you know, and putting everything just right in the universe.
Well, I think it testifies of his love. He didn't consider it too expensive to make a universe of 2 trillion galaxies so we could have this place where we could enjoy life.
Right, exactly. Because he didn't need us. It was perfectly great with what was there. But it, again, goes to his love and what he wanted to do. You're right.